For the polynomial 3x cubed minus 27x, find the following. First, let's find the end behavior of the graph. So to find the end behavior of the graph, we concentrate on the first term in the polynomial. We have x cubed. So the graph of x cubed generally looks like this right here, where it starts in the negative direction to the left and ends in the positive direction to the right. Now, that could be inverted if we had a leading term coefficient that was negative, but since that leading term is positive, this is exactly what our polynomial is going to look like, although there might be something more happening locally. But the end behavior would be the same. So to the left, we fall, so we fall to the left, and we rise to the right. So these are the correct options here for this polynomial. Next, we want to find all the x-intercepts. So the x-intercepts, in order to identify those, we have to find the zeros of the polynomial. And in fact, we're looking for the real zeros. So let's begin by factoring this polynomial. Now, usually, when we go through the process of factoring and finding the zeros, we graph the polynomial first and look for any initial zeros that we can factor out through synthetic division. But in this case, it looks like I can just simply use some common factors here, which would leave me, if I take 3x out of 3x cubed, I have x squared left. And 27x, if we take 3x out of that, that would leave me 9. So this then factors into 3x times x plus 3 times x minus 3. So the zeros that I have are 0 itself, because I get one from the first term of x, and then I have a 0 of negative 3 and a 0 of positive 3. And additionally, I could say that all of these are multiplicity 1, because each of these zeros occurs only one time. And I know that because there's no squared values here. Now, the behavior of the graph at the x-intercepts. Well, the behavior of the graph at the x-intercepts, what happens is, if we have a degree 1, 0, which is multiplicity 1, then the graph passes through the axis at that particular point. If it's multiplicity 2, then it will touch the axis and bounce away. So that doesn't happen at any of these x-intercepts. So the only x-intercepts that we have are the x-intercepts at 0, negative 3, and 3, where the graph crosses the x-axis. The y-intercept. Okay, so the y-intercept of any graph occurs when we set x to 0 and solve. And the polynomial that we have here is 3 times x cubed minus 27 times x. And when I plug 0 into this polynomial, I get 0 right back out, which means the y-intercept is located at the origin, or 0, 0, because it's where x is 0 and y is 0.